वो अटेंडेंस फॉर्म में ना जरूर लोग इस पर जरूर
Okay, I think we should start now. We are already late by 10 minutes. Yeah, shall we start?
Yes.
Yeah. Okay, so in the first session, we have seen how we started with the data. Like once we get a raw data, what are the initial steps that we need to perform? And it is also like very subjective. It is not the compulsory way, like what I perform, that you should also perform when you get a data. It's completely like as the more experience you get with various kinds of data, the more kind of approaches that you learn, you may apply accordingly as well. Okay, but however, as a beginner, I would definitely go with these steps, elementary steps that we have just seen in the first session. Okay, so the all the backgrounds that we have built till uh, till this point of time was all about handling the data cleaning process. Okay, which was introduced or which we need to do because of having some uh, problems in the data, and that was because of your noise in data. This noise I interpreted as either it would be missing values or your range difference. Okay, that is the third one. Could be because of the presence of categorical data which needs to be converted into like various types of encoding techniques, and then also the presence of outliers could be also the one thing. Apart from that, there are many more data pre-processing steps which may be also like some cases you need to have a solid transfer function. Okay, transfer function where what you want your input columns needs to be converted into some transformation with the help of any mathematical functions which will help machine learning model to learn data effectively, or in fact the uh, learning time would be reduced when you use mathematical functions as a transfer function. Okay, although those are not our point of consideration right now, what we will do is we will consider only a special case where I expect that I have a data set which is carrying missing values. Okay, and I hope you remember that we have already seen some of the missing values in the Titanic data set that we have seen in the first section, where we saw that age was a particular column which was carrying some missing values, and then there was cabin. Cabin was also one of the column which was carrying missing values. Missing values are those where you won't find any value. It may be blank, or in some special cases it would be represented by NaN, not a number value. Null भी लिखा हो सकता है, NaN भी उसे लिखा हो सकता है, और blank भी हो सकता है. ठीक है. Now in those cases, obviously I know that for a machine learning model, the whole effort that we are doing is about, I said that OSEMN. We got the data. Somehow we have transformed the data as well. Okay, which is right now, like, since here only data cleaning process is being done. So we need to check for the any anomaly present in the data or not. Okay, and we find out that we have one major challenge, which is called your missing data, missing values. So I have some missing values in my data. Now what I have to do? Okay, missing values. Because as a supervised machine learning model, if I want to create an application, I need to go through some steps, and that would require data set, splitting data into training and testing. Okay, then training will be fed into a model. This is purely the case when I am expecting that my data set is free of noise. Okay, it doesn't contain, like, I do not have to go for any data cleaning process or data pre-processing process. Okay, it's a very well formed data set. Now what we do is we train the model. Okay, and then once the model is trained, we expect that a new model will be generated, which is called a learn model, which will take this test data, okay, and would predict the output. I hope we know that these are very basic steps that will always be there in the data in the machine learning models. Okay, and we are somehow in the process to get this data, which is free from noise. Free from noise. Okay, imagine if the data set here itself, which we want free from noise, is carrying noise in the form of missing values. What will happen? Then in that case, either the model should be smart enough to handle that noise, okay, or before feeding the data into the model, you have to take some appropriate measure so that you can handle those noisy values. Okay, or the missing values. Abhi, whenever I'll say noise, so I am actually stating, or I am referring basically missing values. Okay, missing values. Noise are various types, but I will be right now emphasizing only on missing values. And reason I said because we are going to discuss a paper, a very recent paper, which is actually based on missing values. Okay. तो क्या करें अब? Like, we have now problem. We have a data set. Some columns are there. Few columns are carrying missing values. This is the challenge. Like, this is the problem we have. And now we have to look for the solutions. Okay. So in these solutions, obviously, I expect that I have a very layman model, which is not smart enough to handle the noisy data. Okay. So I need to have some measures which can handle those noise. So for that, we have again missing values handling by two approaches. Okay, they will be done again in the one would be removal. Simply select those rows which are carrying not a number, missing values, or null values. What you will do is you will simply remove those rows. ठीक है? This is very like first step. कोई भी कर सकता है ना कि you have a data set which does not have a column or a particular cell which does not have a value. What you will do is okay चलो ये है इसको delete करते हैं. Let's see कि how many instances are we left with. ठीक है? This is the first step that we can do. ठीक? Removal of instances carrying missing values. ठीक है? First step. Or the second step is introduce some values on the missing values. Introduce some values, right? And now I'll not remove that particular rows. I'll introduce some values, and which is called imputation. मतलब क्या करोगे आप? Instead of having that empty field which was represented by null or not a number, you will actually put a value over there. ठीक है? अब this is again very subjective. One can put any number, ठीक है? And one can have some strategy to put that number, ठीक है? And based on those strategies, various methodologies have been introduced. ठीक है? देखते हैं क्या. The first thing is, while imputation, again, it is categorized into univariate and multivariate. Can you tell me like how this can be related with the univariate? Like I related univariate and multivariate like when you are depending only on single column or when you are only analyzing single column, at that time I would say univariate. Multivariate matlab when you are depending or analyzing more than two column. है ना? That is multivariate. Like suppose age was a column which was carrying multiple missing values. Okay. If I am only looking for the age column and coming up with a criteria for imputing a value in the NAN or a missing value by only looking the age column would be univariate analysis. Okay. And some may what the other guy can do is he want to impute a value in a not a number or a missing values by looking age as well as the other column also. Okay. So this is how the imputation is divided. Like one is univariate, which will be relying only on a single column, and multivariate, which will be relying on all the columns. Okay. So univariate में क्या कर सकते हैं बताओ? Any guesses? If I want to remove missing values of a single column by looking onto that column only, what I can do? Yeah, the first thing is I can do is I can replace that not a number with mean. I can also replace it by median. Okay, mean or median. Now I'll tell you when I'll use mean and when I'll use median. I said I introduced one term in the morning called normal curve. This is the normal curve. ठीक है? यहाँ पे इतना gap नहीं होगा ना. And this is like yeah, this one. Okay. And in the normal curve, which is your this ideal normal curve or standard normal curve, the mean is always 0. Okay. Then you have standard deviation, which is represented by sigma. Then you have plus 2 sigma, then 3 sigma. Similarly here also minus sigma, 2 sigma, and minus 3. So if you observe this graph or this curve, approximately 99.7% of complete area, which is this area, is captured by the area of this curve, which is your area from minus 3 sigma to plus 3 sigma. It's a standard rule. Okay, it's a standard rule. And when you have a data or when you have a column which is following standard normal curve, go for the imputation. Yeah.
स्विच ऑफ कर दिए।
अच्छा, yeah, okay. So I'm saying that when a particular column is idealizing normal curve, specifically standard normal curve, then go for mean imputation. मतलब क्या करोगे? All the not a number or a missing values will be filled by this value. Okay, whatever the value is this. ठीक है? मतलब इस केस पे क्या होगा? If it is a standard normal curve, so you have to fill it by 0. Okay, ठीक है? And if it's not a standard normal curve, it means it will be a normal curve. Then उसका respective mean जो होगा, that will be filled into the, ठीक है? ठीक है? उस केस पे क्या होगा? Mean will be something not 0 in that case. Standard normal curve में mean will be always 0. ठीक है? ये तो clear है. When to take median? When you have curve which is skewed or maybe this one is your left skewed, right skewed. In this case, if you try to fill not a number or a missing value with the mean, तो mean यहाँ पे कहीं पे, mean is somewhere around here, ठीक है? Then in that case, if you try to impute the values with the mean, क्या होगा बताओ मुझे? Any idea on this? This curve will be disturbed. Why? The distribution curve is based on histogram, if you remember. And histogram is what? It's basically frequency of each of the values. ठीक है? How many times it appeared? Frequency कितनी बार आया? अब if you are imputing this mean value, तो इसकी जो size होगी, the amount of mean value would now be increased. Increase हो जाएगा. Okay? So this curve will slightly shift towards this, like this हो जाएगा. And if it happens this, what will happen? I said I gave an example of winter wear वाला. The training data का distribution would be different and testing data का difference, अगर distribution difference तो क्या होगा? Machine learning model will not be able to learn the pattern. Are you getting my point? मतलब before imputation, the distribution curve was different. After imputation, distribution curve has been changed. So I should remember that any imputation that I am performing, my distribution should not be disturbed. Clear hai? Okay, so distribution disturb nahi hona chahiye. That's why in those cases when your data have skewed or data skewed hai, in that case impute with median value. Okay, because median is not going to disturb the distribution. I hope this one is clear. Any doubt on this univariate mein mean median pe? ठीक है? Okay. Chalo, let us see the second strategy. What could be the other strategy apart from mean median? बताओ. Any idea? What else I can impute? 0? Why only 0? Maybe someone may say 100. Or if 0 is a part of that column, age में 0 was a part of column. तो significant है ना? Are you getting my point? Okay. चल अब बताओ random imputation. Now what this random imputation is? I'll make sure that whatever the value that I'm going to impute should not be part of that column. Okay, and I'll take a value and I'll keep on imputing it. That would be random. Okay, probably suppose age may, if the age is from 1 to 70 hai agar, so I'll make sure that the value that I'm going to impute onto the missing values would be not from the 1 to 70. It should be beyond or less than 1 or greater than 70. Probably I'll select 99 and impute that 99 all to the missing values of that column. Okay? This is what we call random imputation. Random imputation. Okay? And obviously इस केस पे भी what do you think, whether the distribution curve will be disturbed or not? Distribution curve will be disturbed or not? It totally depends in both the cases, like every cases. Amount of missing values are less than 5%. Okay, are less than 5%. Then it is better that we look for these solutions, univariate, mean, median, or random. If it is beyond 5%, better to go for the multivariate. Okay, multivariate. That's not actually like a universal rule, but just imagine if the amount of imputation that you want to perform is having more than 5 or 10%, take more than 10%. So that will definitely disturb this curve, this distribution curve. And once this distribution curve is disturbed, take care. I'm not worried about the training environment. I am worried about testing environment, because training would be done in any manner. है ना? If you have disturbed the distribution curve, then also training तो होगा ही होगा. But testing में again the data will come. It will follow the same distribution curve which was before imputation. है ना? So I don't want that to be disturbed, and because of that, I'll apply univariate imputation only those cases when my imputation would be less than 5% of the complete data. ठीक है? तो 99 भी अगर 5% डेटा से कम है तो it won't affect your distribution curve. 5% of the data, है ना? Okay. Random. What else we can do? We can also use end of distribution. End of distribution मतलब what we can do is, see, in this curve, the end is this area and this area. Okay, I want to impute. What I can do is I can fetch a value from mean, from mean plus 3 sigma or mean minus 3 sigma. Okay, plus 3 sigma matlab what? I moved myself at this position, plus 3 sigma, and minus 3 sigma matlab I moved myself to this position. And now I can take the value mu plus 3 sigma and mu minus 3 sigma as an imputation value at the missing values. Clear है? हाँ, this is what we call end of distribution. मतलब distribution के end से देखो, obviously this will also not disturb the distribution curve. Why? Because you are imputing which value, which are already very less. They are already very less because they are kept on the extremas of the normal curve. So if you impute these values, they are not going to disturb the normal curve. मुझे बस ये I have to make sure that my distribution curve should not be disturbed by if I am like applying any approach. ठीक है? If you want to impute with something else, कर लो, but it should not disturb the normal curve. Clear है? Okay. This is what end of distribution. There can be also arbitrary. Arbitrary. Check the spelling है ना? Arbitrary. This arbitrary is, देखो, we have discussed mean, median, random भी कर लिया. Random is something the value will not be from the sample. उस column पे वो value नहीं होगा. Arbitrary क्या होगा? Arbitrary is like random only, but this time the value would be in sample. समझ रहे हो? मतलब अगर age is 1 to 70 था, तो in the case of random imputation I said don't take value between 1 to 70, take value beyond 70. So I took 99. But in the case of arbitrary imputation क्या करना है? 1 to 70 में you have to take a value arbitrary which is between 1 to 70 only. 65 or 60 or anything. ठीक है? Take this value, put in the missing value. This is what we call arbitrary imputation. ठीक है? But this will what? This will disturb the distribution curve. ये थोड़ा disturb करेगा, है ना? Because you are actually increasing a value multiple times. Like how many, like the number, if the 5% of the missing values, तो whatever the like 65 आपने select किया, तो initially its strength was suppose 60% रहा होगा वो, or 20% रहा होगा, तो now its strength after imputation will be 25%. You have increased that value 5%. ठीक है? This will disturb the curve. So like obviously 5% है, तो I expect that the distribution जो disturbance होगा that would not be significant. Significant distribution difference would actually deteriorate the performance of your model. You know, and this is what I have to take care of. I should take care of such situations where significant distribution difference should not be there. Okay? Okay. Okay. These are the steps which, like, these are the few of the methods that you can perform on real columns. Real columns. Matlab, all those columns which are carrying real values. Can I apply mean median onto a column which is having categorical data? Just understand my question. I'm saying that if my column is categorical, and now there are some missing values in my categorical column, can I use mean or median on that? नहीं, है ना? क्या करेंगे वहां पे? There is one more M, that is called mode. Mode is what? The maximum time a particular value that came into a categorical data, that is called a mode value. Okay? So this mode will help you in categorical. Okay? So in categorical case, you have mode imputation. And what else we can do? Just think, like if you think, you will get a solution, and that solution is basically already a methodology given by a imputer method. बताओ और क्या कर सकते हैं? If you have a categorical data, like we already explored the real values वाला. Real पे we thought mean median हो सकता है, random हो सकता है, end of distribution हो सकता है, और arbitrary भी हो सकता है. But in the categorical, we have only right now mode. What else we can do? Can we apply random? A value, instead of having missing value, I'll directly write random. मैं random ही लिख देता हूँ. Characters पे random, all the places where missing values are there. That could be also one of the solution. What I did is, instead of having NaN, now this character, this string will be represented as a value in that particular cell. Okay? I can use this. And what else? What else? वैल्यू के एवरेज पे कैसे? मतलब दिस इज कैटेगोरिकल ना, कैटेगोरिकल पे तो एवरेज नहीं निकलेगा ना. हाँ, तो बट रिलेशनशिप कैसा? ये तो वही हो गया कि रैंडम में तो लिख दिया बस लिखने के लिए, ऐसा है ना? वैसे नहीं होगा. ओके ओके, ठीक है. वो नाउ अब हियर आई प्रपोज वन सॉल्यूशन. ठीक है? एंड you will surprised to know about that was a solution given by an inventor in a competition which is called KDD Cup. ठीक है? KDD Cup. I guess it's a 99 वाला challenge data set था, KDD Cup, where this data set is on intrusion detection. ठीक है? And they have already developed a model, okay, and which was correctly predicting the classes. Okay? And what they said is, whosoever will propose a model which will increase the accuracy by at least 10%, okay, by at least 10%, they will get a good hefty amount as a like winning prize. Okay? Now many of them participated and came up with lots of solution, but the winner that proposed a solution have achieved the improved accuracy of 10 point, I guess 03 or 07 was, I'm not remembering exact figure, but they have improved the accuracy of the proposed model, or in comparison to the proposed model, which the already developed model, sorry, okay, they improved the accuracy. And the surprise was that they only did imputation. Like the model which was already used in the model, that was the machine learning model which was used in the developed model, that was already used in this model. But what they did is they have used one imputation method which is called random indicator. Now what is this random indicator? ठीक है, अब देखो what they did is कि age वाला column, for instance, I took Titanic data set, age वाला column is carrying some missing values. So there would be some, यहाँ पे कुछ value होंगी 50, 45, 70, and then यहाँ पे NAN, and then again 95, 85, and something like that. This is the column. ठीक है, and they propose a solution that what you do is, if a column is carrying missing values, you create one more column, that is age underscore indicator, like this. You create one more column, and this would be a binary column where if you find NaN or a missing value, indicated by 1, and the rest would be indicated by. Okay? So this is the particular column which is denoting that if that column is having 1, or the row of that column is having 1, so that particular row is saying that if ye missing wala tha or ye. And then in the next step, what they did is they replaced this NaN with the mean value, with the mean value of that particular column. Okay? So ye mean imputation bhi lag gaya. And after that mean imputation, they applied this random indicator. And with this change only, they achieved this improved accuracy. Okay, this is what random indicator is. Right? This will add one more column and will help classifier to deal such instances in a different manner, so that now your classifier can also distinguish between the instances, that which instances are carrying missing values and which instances are not carrying missing values. Okay? Okay. So this is how you can also perform, like this was in the case of the numerical values. The same thing can be done in categorical also. If you have categorical values over here and any categorical value which is carrying missing, तो वहां पे क्या करना है? Just indicated by this additional column. ठीक है? तो वहां पे भी 1010 and it will do the same thing. This is how missing indicator will help you in both numerical as well as in the categorical data too. This was all about univariate analysis. Okay, like univariate data imputation. Now, let's move towards multivariate imputation. Okay, multivariate imputation. And here, the two most popular methods are KNN imputer and iterative imputer. See, before this, I should have like introduced those things, but I forgot to introduce. Basically, we have three types of missing values. Okay. The first one is MCAR, missing C stands for completely, at, explain these three scenarios with the help of an example. For the first case, MCAR, let me take a suitable example. Okay. Uh, let's imagine that I conducted a survey across the 31 NITs, 31 NITs for the CSE or IT department, okay, specifically for final year student, that how many actually failed in final year. Okay. Okay. So 31 NITs for these two departments final year, and how many failed. Okay, the amount, like I am interested in the the failure peoples. Okay. Now, when I conducted survey, maybe because of some issue for some NITs, I was able to collect the data very correctly. Okay. And for some NITs, that too for some student, I wasn't able to collect the data. Okay. I wasn't like, what I'm saying is for some NIT, that too for some students. Like I did collected the data of the students, but not for all students. It is for some students. This is a particular case where I can say that missing completely at random. Missing completely at random. Matlab, there was no intention to miss the value, but it was missed because of certain situations. And surprisingly, you can find that, okay, even if you miss those values, you can still get the inference, you can still get the knowledge, you can still get the information about whatever you want to predict. Matlab ki whatever you have missed will not give much of the influence or much of the effect onto the your predictions. Clear hai? Huh? All those samples will not give significant contribution towards the prediction. You can still get the idea of failure people. Okay, so MCAR is a place which is not dangerous to you. Okay, and still you can cope up with it until and unless if the MCAR data are greater than 10%, 20%, 50%, tab sort of significant danger. Because in that case, you don't have significant amount of data for prediction itself. Tab MCAR will be very dangerous. I hope you got my point. MCAR. If I see MAR, missing at random, this is where now I'm like MCAR was saying that the whatever the values are missing, they are not going to be influence, or they are not going to play much role in the prediction. That's why it's basically they have like no relationship between the attributes. Okay, and in MAR, what now there would be relationship. For example, your age wala column, where you're conducting a survey for where I can take the some amount of people haven't given the information about their ages. They want to hide their age. Okay, and some have given their ages, but that age would be playing a vital role for the prediction. Hello, hello, yeah, anyone? Yeah, okay. So there would be some relationship between the attributes as well as missing values, है ना? Missing values and attributes के बीच में relationship होगा. That is what MCAR and MAR. NMAR is intentionally deleted. They are intentionally deleted. For example, you conducted a survey for an IT firm to know their compensation package or salary. Okay. So in that survey, the data scientist were like, they decided, all the data scientist people, they decided that they would not be going to participate in the survey. ठीक है, तो उस केस पे क्या होगा, सैलरी वाला जो कॉलम होगा डेटा साइंटिस्ट पे मिसिंग हो जाएगा. फॉर ऑल द डेटा साइंटिस्ट मिसिंग वैल्यूज वुड बी इन द सैलरी कॉलम, बट फॉर रेस्ट इट विल बी प्रेजेंट. तो दिस इज व्हाट नॉट मिसिंग एट रैंडम. ठीक है, तो मतलब देखो, दिस इज अ पर्टिकुलर केस NMAR which is intentionally deleted and which is quite helpful for the developer. ठीक है, we are not going to worry about this situation. We are going to worry about only these situations, MCAR and MAR. And MCAR जो है, this is like, it is better that its amount would be obviously less than 5% or 5%. Then what we can do is we can go for any of the imputation that we have discussed till now. What are those? Those are mean, median, random, end of distribution, arbitrary. Then you have random imputations and the missing indicators. Okay, so you can use these imputations in the case of MCAR. In the case of MAR, it is better to go for multivariate imputation. Okay, because there are now dependency between the columns. There would be some relationship between the columns, and in this univariate, what you are doing is you are only analyzing single columns, है ना? तो जब relationship है columns के बीच में, तो it is actually useless to apply univariate. Go for multivariate, and in that case, KNN imputer and iterative imputer will help me out. How they will help me? Just see that. KNN. Yeah, this is very like popular algorithm in the machine learning. This is, and it is also like inferred from that algorithm only. This is called K nearest neighbor. How it works? It's also called lazy evaluation algorithm. It takes complete data, it does nothing. It's compute the Euclidean distance, है ना? And based on the Euclidean distance of the each data points, what you do is you decide the K values, the K closest point, majority of the K which is lying onto the like corresponding classes. You will simply what predict that key its class would be the K majority classes. Okay. Okay. So the similar phenomena will be also done in the case of data imputation too. Kaise? Like, obviously, there would be, suppose features are your, let me take features to be, suppose you have feature F1, F2, F3, F4, and then you have labels Y. Okay, Y, and the instances are something like this: key 2.5, 1.3, 0.7, then this missing. Then F2 pay you have 95 missing, 45 missing. Then यहाँ पे you have minus 1.2, 0.7 missing, 0.3 missing, 25, 1, 4. And the labels are, this is for 0 and this is for 1. ठीक? So the data set belongs to the binary class. You have two class labels, 0 and 1. Right now, I have only taken 4 instances. Okay? And I am interested in these missing values. I need to propose a solution where I can put the values of this dash with some other values. You know? And I'm saying that for that, I'll use KNN. What I'll do is, suppose I want to like fill this value. I'll compute the distance of this data point. This is my data point 4, DP4, DP3, DP2, and DP1. I'll compute the data point distance from DP4 to DP3 to DP2 to DP1. Okay. And how I can compute the distance? It would be done by, yeah, Euclidean distance. What is the formula? The formula is, it's simply x2 minus x1 whole square plus so on and so, like जितने भी उसमें coordinate points हैं. How many coordinate points are here? 4 coordinate points are there. ठीक है? But surprisingly, this Euclidean distance formula will not work over here. Why? Because if you see data point 4 and apply the Euclidean distance on dp3, you have missing value in this, you have missing value, तो इनका difference क्या आएगा? That would be an error, है ना? इसका difference, that would be also an error. The only difference that can be computed right now is this data point, like this data values 1 and 4. ठीक है? So it means कि do I need to compute only 1 minus 4 का whole square का square root? This is the distance? No. We need to also consider these data points. But since because of the missing values, I could not apply Euclidean distance, I would apply NaN Euclidean distance. Now this is not slightly modified form of Euclidean distance. I'll show you how. NaN Euclidean just see how it is computing. देखो, to compute the distance, okay, I think it won't work. We have two coordinate points, 3, not a number 6, 1, not a number 4, 5. To compute the Euclidean distance in the case of not a number, how they're doing is, see 3 and 1. The first coordinate of both the data points are number. They will be used 3 minus 1 ka whole square, as well as the last value 6 and 5. They both have the value, so they will be used as it is in the Euclidean distance. Okay? And for rest of the data points where you are not getting any not a number in any of the cell, you won't be considering it to the Euclidean distance. What you will do is you will directly use a formula called total number of data points. How many data points coordinates are there? 1, 2, 3, 4. Okay, 4 data points divided by how many number of present values, how many number of cells that where the values are present. It's 2. कहाँ पे? 3, 1, 6, 5. 3, 1 and 6, 5. यहीं पे 2 पे present है. So that's why total number of columns are 4 divided by number of data values present. 4 by 2 multiplied by the present square. This would be Euclidean distance between these two data points. Okay? Okay. Now, if I come back to my case, in this case, if I apply, what would be the solution? बताओ मुझे. dp3 और dp4 के बीच का distance would be 1 minus 4 का whole square. This will be 1 minus 4 का whole square. These two data points. And then यहाँ पे भी missing है, यहाँ पे भी missing है, तो and this one is missing. तो ये these three will not be considered. So instead, what I'll do is 4 is my total present. Divide by how many matching? Only 1. This would be the Euclidean distance between dp3 and dp4. Similarly, you can also apply the same formula for dp4 to dp2 and dp1. How many distance you will get? You will get 4 distances. है ना? In fact, 3 distances. Sorry. dp4 से dp3, dp2, dp1, so you will get 3 distances. And suppose you decided k value to be 2. ठीक है? तो जो 3 distance निकला, suppose dp4 के with respect to dp3, dp2 and dp1, the distance from dp4 to dp3 is suppose 2.5 है, dp2 से 1.5 है, and dp1 से it's 7.5. Which two are more closer? It's dp2 and dp3. ठीक है? So dp2 and dp3 are more closer. Now, to fill this value, dp2 का this value divide by dp1 का this value. dp1 sorry, dp3 and dp2 है ना? So not dp1. dp2 and dp3 are closer. So 0.7 plus 1.5 1.3 divided by 2 would be this one. ठीक है? कितना आएगा? 1.3 plus 0.7, that is 2. 2 divided by 2 is 1. ये 1 आ गया. This is how KNN imputer. ठीक है? You have to compute the distance, Euclidean distance, whatever the suitable k value, take the average, put the k value. Clear है? Okay. Now in some cases this could also be modified in like ये जो k value जो average ले रहे हो ना, इसका weighted average भी ले सकते हैं. How? You got this dp2, dp1 and dp3. Like this is the distance, है ना? 1.2 ले लेते हैं. What you can do is when you want, like you have dp3 and dp2, they are closer. ठीक है, they are closer. You can also apply weighted distance formula 1 by 2.5, that is distance multiplied by what was the value of that? dp2 ka is 1.3 plus 1 divided by 1.2 multiplied by what is the value? 0.7 divided by 2. So this is the actually distance mean formula. Either you can directly take the mean of the two values or you can apply this formula to get the mean. Am I clear? Huh? It's very clear. Like KNN imputer is very easy. Okay. This is one approach that through which you can apply KNN imputer. The other approach is your, I said, iterative imputer. Iterative imputer. Okay. This will be the last one, like last imputer that we are going to see today, iterative imputer. And in the lab session, what we will do is we'll take these imputers. Okay, I have library, like I have already prepared the Jupyter notebook files with me, and those notebook file we are going to execute onto the lab environment and just see what are the effect onto the various path. Like k की value अगर increase decrease करते हैं, जैसे I took k2, what would happen if I take k3, k4? Will it improve the model performance or will it decrease the model? So that those things we'll see in the lab. Iterative imputer पे see, and this is very also important from the perspective that we are going to see one research paper which is your deep learning for missing value imputation of continuous data and the effect of data discrimination. Okay, so this iterative imputer is a method which is used in this paper. Okay, I'll tell you how. देखो, let me take the same instances. ड्रॉप होगा क्या इसमें? shape. I'm just using the same data, same table, है ना? That's why I'm like dropping it. Now we are in iterative imputer and we want iterative imputer to see, and I want it to work on this was missing, I guess. Data point 4 pe. Let me remove this, 1.3, remove this. This was my original data. Yeah, this was the original data that we took. Okay, in the case of iterative imputer, as by name, it seems that iterative है, तो that will work in loop. ठीक है? Just listen this algorithm very carefully, because अगर ये algorithm नहीं समझ में आया, तो this ये paper भी नहीं समझ में आएगा. ठीक है? What I'll do is, in the iterative imputer, I'll take a help of a machine learning algorithm. What is the task of machine learning algorithm? क्या करता है machine learning algorithm? It will take training data, its label, like ये क्या हो गया, features हो गए and their corresponding labels. This data will be used for learning the model. Model will be trained. I'll get a trained model. And now this trained model will take new set of feature to predict the values. Am I correct? यही करता है? हाँ? Let's imagine this machine learning model to be logistic regression. एक algorithm होता है. Just imagine अभी इसके पीछे का background मत जाओ. Just imagine that it's a black box which will take some input and will give you output. Output corresponding to 1 0. अगर binary है तो. और अगर real है तो it will take linear regression, not logistic. Logistic is for classification. Linear regression is for the regression. So just imagine, abhi you are applying this logistic regression, or maybe you can also think of applying linear regression also, because we have to ultimately give these values, and you can see these values are real values. Real है ना? वहाँ पे decimal values है. You want decimal values to be there. So decimal के लिए you can also take linear regression, not logistic. Logistic will give you discrete value. ठीक है? अब क्या करते हैं देखो, I'll give you step by step. In step one, fill all the missing values with their corresponding mean of column. ठीक है, क्या करोगे? Compute the mean of f1, replace the value with this. ठीक है? Compute the mean of f2, replace the value here. Compute the mean of f3, replace the value, and compute the mean of f4, replace. Clear hai? Okay. Now what will happen? You will be getting a data set which will look like this: 2.5, let me minimize and see, 2.5, 1.3, 0.7, and then m1 आ जाएगा, mean 1 है ना? Then you have 95, m2, 45, m2 again. Then you have minus 1.2, 0.7, m3, 0.3. Then you have m4, 25, 1 or 4. Okay? And then their corresponding labels too. That is 0, 0, 0, 1, 1. Okay? Clear है? तो ये step clear. This is very easy. Now what you have to do is take the first column. ठीक है? First column. जो m1 वाला था ना, m1, this one. ठीक है? Use this row, that row, as test data, and rest of the other rows क्या करोगे? Training data. ठीक है? And this column as label. ध्यान से सुनो, है ना? This जिसको predict करना है, like जिसमें you have to impute the value, use that particular, like first iteration में first वाला column will be label. ठीक है? तो अब क्या होगा? You have machine learning model with you, linear regression or logistic regression. ये जो बच्चे वाले हैं, this would be feature, this would be label. Okay? Train it. Training हो गई. अब क्या करो? Use this instance for testing. क्या करेगा ये मॉडल? This model will generate a value. करेगा ना? हाँ? ठीक है? Suppose it generates 2.5. Just take this 2.5 and replace this m1. Clear है? हाँ? This is first step of iteration 1. Step 2. क्या करोगे अब step? Like this is step 2 basically. You have used machine learning model. Step 3 पे now shift your लेबल टू कॉलम टू। ठीक है, कॉलम टू पे किसको प्रेडिक्ट करना है? ये वाला रो एंड ये वाला रो। ठीक है, तो रेस्ट ऑफ द रोज को ट्रेनिंग डेटा बनाओ। ओके, मेक दिस कॉलम एज लेबल, other columns to be feature, feed into machine learning model, and again predict the values for the test data. क्या होगा? M2 की values मिल जाएंगी, replace those M2 value with this one. Similarly for M3 and M4 करोगे? For all the columns you have to repeat this. This is your first step. This is iteration 1. In the second iteration, what you have to do is all the values that you have predicted, M1, M2, M3 और M4 ये predict किया था, और इसके पहले वाले values क्या थे? मीन ऑफ M1 निकाला था, बेसिकली M1 डैश, M2 डैश, M3 डैश, M4 डैश, ये प्रेडिक्शन वाली वैल्यूज है। एंड M1, M2, M3 वर मीन। इन दोनों को सब्ट्रैक्ट करो, डिफरेंस चेक करो। अगर ये डिफरेंस जीरो आ गया या क्लोजर टू जीरो आ गया, इट मीन्स यू हैव टू स्टॉप द इटरेशन। अदरवाइज व्हाट यू हैव टू डू इज अगेन कंटिन्यू द इटरेशन। अगेन क्या करो? टेक द फर्स्ट कॉलम, मेक इट लेबल, रेस्ट ऑफ द कॉलम फीचर, make that test data, which one, जहां पे you have to predict, you have to like put them imputation, test data बनाओ, rest को training बनाओ, and so on. समझ गए? This is how this imputation method works. Which one? The iterative imputation. Okay, and you're seeking the help of machine learning model in this particular algorithm, in this particular technique. Acha, okay, before that, let me also so these are some imputation technique. Some are also using discretization for imputation. What is this discretization? Do you know about this discretization? It's basically if you have a column carrying real values, you will try to discretize it. How? Suppose a column is carrying value between 0.0 से लेके 99.05 तक. Suppose what you will do, you will form the bins. Suppose 0.0 say the first bin is suppose 10.0. This is first bin. So all the values which are between 0.0 से 10.0, you will replace it by 1. ठीक है, 1 से. Then the next bin would be 10.01 से start होके suppose it goes to 20.0. So all the values which is lying between 10.01 से 20.0, that would be replaced by 2. What we are doing is we are replacing these numerical values which is in continuous form, we are replacing it by discrete value 1, 2, 3, 4. This is simple discretization and we call it this method to be binning. And this is not done randomly. There should be some criteria, है ना? कभी you will be using maximum gain, कभी entropy, and like on based on those criteria, you will be discretizing the real values. Now, how this value can be used for imputing the missing values? Suppose you have missing values. Hmm. Mm-hmm. Yeah. Uh, I was saying about the discretization, where what we have done is we have divided the continuous value into various bins, and the corresponding values which are lying in the range of those bins will be replaced by their bin index. Okay. So one would be replacing the values which are in the range of 0.0 to 10.0. So in this way you discretize, and not this is the random criteria. The criteria should be genuine. That should be some logical, and normally those criteria are built upon the information gain, entropy, and there are various measures for binning also. But the logic is that missing values which you want to impute will now be imputed by their bin indices. Okay? Matlab, what you can do is you can simply have a bin dedicated for missing values. Okay? All the missing values which will be going to lie into a single bin, just replace with their bin index. Okay? This is also one of the criteria which will help you in imputation. Okay? This is called discretization. Now I'll switch back to the article that we need to discuss for this session. I think I have built uh, a good amount of fundamentals or the elementary knowledge about the imputation. Yeah, I was talking about this article, which is your deep learning for missing value imputation of continuous data and the effect of data discretization. From the topic itself, you can understand, like the title itself, you can understand that it's basically dedicated towards missing value imputation, that too for continuous data. So obviously we are not going to expect that any imputation that we are going to do is on categorical data. It would be done on continuous data, and this will be done with the help of deep learning model. I just explained the iterative imputer model, where we have used, or we have actually took help from linear regression and logistic regression algorithm. Now this paper, what they have done is, uh, obviously if you read the abstract, they are clearly stating that many of have already performed this simulation, performed this experimentation on conventional machine learning models. ठीक है, मतलब जो iterative imputer था, instead of using linear regression or logistic regression, many of them have used already SVM, KNN, decision tree, lots of algorithms they have already used. But prior to this paper none of them has applied deep learning model in iterative imputer. So they took the advantage, the benefit, the challenge that they have, like the gap which they identified by going through the various paper of the data imputation, and they identified that deep learning models are not used as an imputer or iterative imputer. So why not use the deep learning model as an iterative imputer? So this paper is all about that only. They have used two deep learning models, multi-layer perceptron and deep belief network, as an imputer. Okay, as an imputer, and they compared their values with KNN imputer, CART. CART is also like you can also like this is decision tree only. CART is decision tree only. The only difference is it uses Gini indices. Okay, I'm not exactly remembering whether it is using Gini indices or information gain, but the difference is only that while evaluating the criteria, it uses different formula. Gini indices use different, your information gain uses different. Okay. Then they also have compared SVM performance with these two. In addition to that, they have also conducted one more experiment where they have discretized the bin, like they have discretized the missing column, and then see its effect with the help of deep learning model, like how it is affecting onto the deep learning model if I discretize the missing values too. This article is all about that only. Okay, if you read this article in detail, I'll tell you there's they're saying like if you read deep learning techniques have been employed for missing value imputation, demonstrated their superiority over many other well-known imputation method. However, very few studies have attempted to assess the imputation performance of deep learning techniques of a tabular or structured data with continuous value. This was their gap, which they identified. Okay. See, like abstract is a place where everything is given, but that will be given in very abstract manner. Okay, that would be very like you won't be getting as much detail about the paper from the abstract, but at least you will get an idea that what they have done. First three lines, obviously they will introduce the problem. Then some of the lines will introduce that what they have identified. Then their identification lead to a solution. Okay, and then based on the solution, whatever the results they like they like after performing the simulations or the experimentation what they got, and then finally based on the result they conclude what is the conclusion of this paper. Okay, so abstract is carrying all the sections. It is also carrying introduction, it is also carrying your survey. Okay, then it is also carrying your methodology, then result, and then conclusion. But that's not very like detailed manner. It would be obviously because you have to the limitation of abstract is you need to write hardly 300 to 400 words. Okay, some journal limited to 500 words. Okay, within the 500 words you have to represent the all the essential part of your experiment, of your paper. Okay, so when you read the abstract you'll get a very elementary information. Okay, very like बहुत basic information. You won't get much detail. For that you like need to study the rest of the section. Introduction will always give like it will build the background of the problem. Okay, some papers what they do is introduction may they include literature survey also. Okay, what are the works already done in this paper like in this area. Some paper what they do is they introduce in the introduction section some part, and then they also have a dedicated portion for a literature review. Like in this paper they have a dedicated section for the literature review. Okay, up like reading the paper is also very matlab, it's an art. Basically you have to follow each sentence. You cannot ignore a single sentence onto the paper, because sometimes what happens is because like if I see this sentence like the collected data set is usually incomplete with some data samples containing several missing attribute values, and then एक bracket लगा हुआ है वहां पे it is written 1. This means that this particular sentence has been inferred after reading the paper number 1, which is this one, flexible imputation of missing data. Okay, because that sentence is very simple, so you would be getting it by simply reading it once. There would be situation where that sentence would make you to read this paper as well, because you are not able to interpret that particular sentence, and to get the essence conveyed by that particular sentence you have to read the citation of that paper, like the reference of that paper, reference number also. Okay, you have to download that paper, usko read karo, get what they have done. Okay, what were the challenges when they proposed the solution, and how it is like why they referred over here. That is like the question is sometimes in the methodology itself, like suppose somebody has applied an algorithm and simply he won't be giving much detail of the algorithm. What they will do is they will give a single sentence by stating that this algorithm can be referred from this article and simply cite. So in order to understand that algorithm, what you have to do is you have to download that paper and then read the paper to understand the specific algorithm, which is just a part of the paper. Maybe there might be multiple algorithms deployed in that paper. That would be only single algorithm. So as a like it's a chain. You have to follow each chain. Like you have to follow every chain. Okay, it's basically when you draw a pseudocode, step 2 will not execute until unless step 1 is executed. Okay, so in order to execute step 2, you have to thorough with step 1. So similarly, any section that you are reading is carrying multiple references, so those references would be very important. Sometimes that may be ignored because of some careless reading. Okay? And it is very important that you read this paper, whatever the paper that you read in the referring, you should read paper at least 5 times, 10 times at least. Because see, as a beginner, I am not the expert of this particular problem. Okay? I have to build the background of this problem. Okay? And in fact, while our graduation and post graduation itself, we have a syllabus, we have a topic, and for that topic, to understand that topic, we usually refer 2-3 books, more than 2-3 books. Okay? So just imagine that a topic requires 3 to 4 books for understanding the problem. So like a 10 to 12 pages of this article, how this article would help you to build the background? Obviously, every single citation would help you in those situations. Okay, all the citations that has been like 1, 2, 3 references जो भी है, you have to also read those paper multiple times to understand the problem. ये तो this is for understanding the problem and their solutions, various solutions which have been applied in various paper. ठीक है? And not only the reference, sometimes you also have to refer those papers as well, which is not mentioned over here. Okay, you have to look for some other paper also which have addressed the same problem with some other strategies. Because sometimes what happens is, because obviously you're actually proposing a solution, and that solution should be novel enough. Until and unless it is not novel enough, it won't be accepted by the journals. ठीक है? तो novel कब होगा? When your idea is not mapping with the idea which is already published by some reputed authors. Okay, so in that case you should be updated with your area, ki what is the work that is going on. Okay, and I need to collect, I need to have a repository, I need to have a dictionary where I should be updated with all the current work which is going on. समझ रहे हो? Okay, so these references are very important. Reading every single sentences multiple times, multiple sections, like multiple times reading every section, that is also very important. And especially this literature review wala section, most of the times, like once when you are good to go with some papers, like you are done with some paper, you have done reading, you have built some foundations, so most of the time this section is being ignored, but I prefer this section is very important, because this will give you an idea that what the current authors are doing right now. Okay? And in fact, whatever they have mentioned is not the current work. They might have referred an article which is also 5 to 10 years back. Okay? So in that case also, you have to make sure that you also collect those papers which are currently under the maybe under process, under review in some, because nowadays what happened is you have platform like archive, or then you have research gates where author upload their paper while like the review process is going on. Okay, so that will also give you an idea कि okay यार ये तो अभी this is under the process, under the review, and he uploaded this paper, so obviously there would be some novelty, that's why the paper is under review. Okay, so the associate editor will always see paper and through the paper if paper has some novelty. Okay, so while going through the various section of this paper, I find out that in the first section, in the literature review, they have reviewed missing value imputation methods, and in the later on sections, the second section is dedicated for data discretization. Then they have deep neural network, because if you see, the title is basically focusing on missing value imputation, then data discretization, and the deep learning. So that's why they have reviewed missing value imputation, data discretization, and then deep neural network. And in the deep neural network, they have worked on 2 networks, multi-layer perceptron and deep belief network. So it's like the arrangement is very systematic. This is not a textbook where you have to give every information. है ना, you are being limited by the length of the pages of your manuscript. Sometimes this is the constraint given by the journal, okay, and you have to follow those constraint. So one constraint could be the paper length should be of 10 and 12 only. So in that case, you have to only like write the very, you have to summarize the techniques in a very shorter form, okay, and that can be done by okay, and you have to also refer many paper for writing as well. Until unless your reading is not good enough or as large as uh, the kind of representation done by the various authors, you won't get an idea that how you are going to write the paper which would not have plagiarism content and also give some additional kind of representation which was not done by the earlier papers. That would be like a novelty presentation or novel presentation of a uh, of a of a paragraph or of a topic which was also not dealt by the other. So that would also be one of the novel thing that we can introduce while writing in the paper as well. Okay. Up see, in the experimental methodology, what they have done is first they, in fact, I would also like to mention here is I was introducing this topic. Which one? This one. There are three types of missingness mechanism: missing completely at random, missing at random, and not missing at random. You know, and we have seen their examples as well. Okay, while going through the multivariate imputation. Okay, our interest is not to focus on NMAR. We are always going to focus either on MCAR or MAAR. Okay, and since this is of iterative imputation, so they are focusing on MAAR, है ना, iterative imputation. In addition to that, data discretization भी use किया हुआ है ना. So discretization is nothing like continuous value को you have divided into bins and bin indices will be used instead of values. ठीक है. See, in the experimental methodology, okay, you can see this diagram, the flow diagram. What they have done is the original data set is divided into two parts: the training set and testing set. In fact, this training and testing set is k-fold. मतलब this will be repeated 10 times. ठीक है, 90-10 पे तो 10 times repeat. In the 90%, missing data simulation हो रहा है, which is like incomplete data, and then complete. Like अब यहाँ पे this is a sort of iterative imputation is going on. ठीक है, iterative imputation. And then with the help of iterative imputation, what will happen? Whatever the missing data would be there, it will be like you will be getting a complete data set. Okay? Iterative imputation में they are using two algorithms. Deep learning में what are they? One is multi-layer perceptron and the other one is deep belief network. Okay? We took the example of LRN, logistic regression and linear regression. है ना? What they have done is simply linear or LR को हटा के they have used deep belief network and multi-layer perceptron, because these are the algorithms which is right now very a buzzword. Deep learning and the techniques are in fact not the buzzword, they are also very productive in terms of higher accuracies. Okay, there are some applications where they have given 100% accuracies too. Okay, so what they have done is replace your conventional machine learning models with the deep learning models and form the complete data set in the cases where you have missing values. Okay. Then the other experimentation that they have done is discretization plus missing value imputation. Okay, so now they have divided into bins, and then those bins are represented by their indices. Missing values will also be represented by their indices, and you have a new data set to which you can again evaluate the performance. See, DBN and what was the other one? The multi-layer perceptron. both the algorithms are used for imputer, they are not used for the classifier. देखो यहाँ पे, here you have a classifier, मतलब after the data set completion, or you have a non missing value data set, मतलब a complete data set which is not carrying a single missing value, they are generated from DBN and multilayer perceptron. But ultimately, once the data set is created, that data set needs to be again evaluated on some classifiers. They have used SVM for that. ठीक है, SVM use किया है. I'll show you how. देखो यहाँ पे लिखा हुआ है, two deep neural network, multilayer perceptron and deep belief network are used for missing value imputations. Okay, and classification accuracy of the SVM classifier. They have used SVM classifier for the performance of the complete model. Once you got the complete data, fill it into the SVM classifier. Okay, so they are actually testing the performance of two deep learning model for the imputation cases, for the data imputation case. Okay, and here you can see various tables when they have imputed. देखो यहाँ पे लिखा हुआ table 3. If you see the caption, they are saying that classification accuracy of SVM, मतलब classifier is SVM, for the 10% missing data, they compared with mean imputation. We have seen mean imputation. देखो यहाँ पे mean imputation. Then KNN. Here KNN is used as an iterative imputer, not KNN वाला imputer. ठीक है, iterative imputer. मतलब जो algorithm था यहाँ पे, that was K nearest neighbor, not KNN imputer which we have seen before iterative imputer. ठीक है. CART is again what? Your iterative imputer algorithm. यहाँ पे SVM is also one of the iterative imputer. Don't be confused कि यहाँ पे दो SVM हो गया है. One SVM is an iterative imputer and the other SVM is the final classifier. ठीक है. Similarly MLP and DBN also. So the comparison is between imputers, not between the classifier. Classifier is fixed, SVM is fixed. Okay. Similarly, by changing the variation of the layers like deep belief network, or because you have layers, since this, like I don't have sufficient amount of time to explain the deep belief network or multi-layer perceptron. Just imagine that it's actually a layer by layer network, okay, where each layer will perform some mathematical operations to get the latent information which is hidden in the original data, okay, and map those latent information with respect to your class labels. ठीक है, सिर्फ इतना ध्यान रखो. Furthermore, they have also carried various your performances evaluation and their comparison with the help of chart as well. You can see that the missing rate, when the missing rate is increasing, like when you have 10% of the missing data, 20%, 30%, and so on, the performance of the model is tend to be decreasing, because as much as you have missing values, obviously machine learning models will not be able to learn the patterns, and obviously that would like deteriorate the performance too. Okay, you have again, when you have 20% of the missing values, this is with respect to 30% missing values, 40% and 50%. So they conducted these many of experiment. They actually, up see, for this also, how many data set they have collected? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 data sets are there. And in fact, if you see this data, blood, breast cancer, E. coli, glass, ionosphere, iris, liver, these are benchmark data set available for classification. Okay, they are classification data set. And in fact, surprisingly, none of the data set is carrying missing values. What they have done is they have intentionally deleted some cells from this data, okay, and then perform the experiment. Because just imagine if you have a missing value data set, okay, and somehow you got the missing value, how you're going to validate it? You don't know what is actually the missing value. Until unless you know the actual missing value, then only you can say that the predicted missing value and the actual missing value is the difference, like you have some difference. So that's why these are some benchmark data sets which is readily available. There are lots of data sets available for classification, but these are very popularly data sets which are very often used for various classification, performances, measurement, and these are the benchmark data set in fact. So they intentionally deleted 10%, 20%, 30%, 40%, 50% of the complete data set. Okay, and perform these many of experiment with, like, you can imagine the exhaustive experiments that they have performed. They have also done mean imputation, KNN, CART, SBM. Matlab, for one table generation, they have to perform 14 benchmark. 14 benchmark mein they have to perform 6 imputation techniques. Okay, and then that too, it's a tenfold cross validation. So one data would be divided into 10 sections, 90, 10, 90, 10, 90. समझ रहे हो? So the amount of time taken for getting one table would be very enormous. Are you getting my point? So it's very exhaustive experiment that they have conducted. Then you have the average processing time also mention कर दिया यहाँ पे इन्होंने, ठीक है? And in fact, MLP and DBN are consuming more time. Okay, and I hope you know what is the reason behind that. They are deep learning models. Okay, they run parallelly. It would be beneficial if you have GPUs with you. Then in that case, they may take less amount of time, but the amount of mathematical complexity introduced in MLP and DBN is quite more in comparison to CART, SVM, and KNN. That's why their runtime complexity is very high in comparison to the other algorithms. Okay? Then what are the average classification accuracy of SVM by, in fact, the same experiment done with discretization also. Okay. And rest, like, I would request you all to go through this paper, and I just gave very abstract information, like what initial view about this paper. Once you go through this paper, you'll come to know that why this performance, like why the model of the performance is better in comparison to the other. They must have mentioned the reason also, and why only these specific set of experiments, like why not other, like why they haven't given the values of precision recall, or why not AUC is mentioned. You need to ask these questions by yourself when you're evaluating or reading the paper. Okay, evaluating, I mean to say, when you maybe sometimes you might be getting a chance to review a paper of a conference or a journal. In that case also, you need to ask these questions, like why only these specific set of performance measures being used like for performing, like for showing or displaying the performance of a model, or for visualization of the performance of a model. So uh, I think that's all for this paper discussion. If you have any doubt, you can ask. Otherwise, like, discussing a paper for 15 to 20 minutes only is not the ideal case. You have to read this paper multiple times. Okay, follow these steps, implement these steps. Okay, then only will come to know about the core sense of why they have conducted and what is the, like, outcome of the experiment. Okay, if you have any doubt, you can ask. The paper is more relatable to the topic that we have discussed in the second session. It's about data imputation only. Okay, and in fact, the data imputation technique that we learned, iterative wala, was proposed 20 years ago only. And you can see this paper, which was published in the year 2022 itself. Still, people are working on the area, and they are able to get the paper in a reputed journal by simply having a general idea about the data imputation. It's not like if you see कि बहुत mathematical contribution नहीं है इसमें, you won't see any mathematical expression as well. Okay, but the thought behind is to evaluate the performance of deep learning model with an iterative imputer when it is working as an iterative imputer. Yeah, any question?
Any question from your side?
Okay. So, madam, any announcement for the coming session?
Yeah. First of all, we'd like to thank Dr. Deepak Singh
Thank you.
sir for his excellent lecture. And if you have any doubts, you can ask. Okay. So I request you all to gather here again at 2:15. Okay, take your lunch fast, and we will gather here at 2:15. Okay. Thank you so much.
Thank you. Thank you, madam. Thank you.